Let's try and discuss this question. What does the question say? Find sine x by 2, cos x by 2, tan x by 2 in each of the following. We are given tan x equals minus 4 by 3 and x lies in quadrant 2. Okay. How do we go about solving this? Let's see the question. Tan x equals minus 4 by 3, okay, and x lies in quadrant 2 will imply that quadrant 2 will imply that x is greater than pi by 2, less than pi, right? Quadrant 2, this is from quadrant 2 implies that x lies in this interval, okay. What about x by 2? X by 2. X by 2 will be greater than pi by 4 and less than pi by 2. Can you observe that? Yes. So x by 2 will lie in the first quadrant. Can you observe that? Yes. This is less than pi by 2. Remember the quadrants? Yeah. This is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is again 2 pi, right? That's what you have. So second quadrant implied that the angle lies from pi by 2 to pi. Yes. And division by 2 implied that x by 2 would lie between pi by 4 and pi by 2. Pi by 4 is somewhere here, pi by 2. So this is the line pi by 4 in this interval. This is the region in which x by 2 will lie. Okay. Now given tan x equals minus 4 by 3, do I have some relation between tan x and any of these? Yes, I have a simple relation between tan x and tan x by 2. Can I use that relation? Yes. What is the relation? Tan x equals 2 tan x by 2 over 1 minus tan square x by 2. I have a simple relation, direct relation between these two. Let's use that. Since tan x equals this gives me 2 tan x by 2 over 1 minus tan square x by 2 is equal to tan x. Tan x is minus 4 by 3, as you can observe. On substituting this, do you observe that you have a single variable in this equation, that is tan x by 2. Can you find the value of tan x by 2 for me? Yes. So let's simplify this. We'll get rid of this one over here. And let's simplify this. What you get is 3 goes over here. This becomes 6 tan x by 2, which is equal to minus 4 times this, which is minus 4 plus 4 tan square x by 2. This is what you get, right? Let's try to solve this quadratic. This is 4 tan square x by 2 minus 6 tan x by 2 and minus 4 in the RHS over here. This is what you have. We can divide by a factor of 2. We can divide by a factor of 2. And is there anything else? Yes. 2 tan square x by 2 minus 3 tan x by 2 minus 2 is equal to 0. 2 times minus 2 is minus 4. This can be this. We can split the middle term to get the roots. This will become minus 4 and plus 1, right? Tan x by 2. This is 2 tan square x by 2 minus 4 tan x by 2 and plus tan x by 2 minus 2 equals 0. Do you observe this? Yes. After reaching this stage, you can observe that one of the factors tan x by 2 minus 2 will get out common. The other factor is 2 tan x by 2 plus 1, which will be equal to 0. This is what you get, right? 2 tan x by 2 will come out common from here, from these two terms. What remains is tan x by 2 minus 2, same as this. 2 tan x by 2 plus the other factor 1 will come out over there. Therefore, the value of tan x by 2 that I obtain is 2, or tan x by 2 is equal to minus 1 by 2. Now mind you, x by 2, we already remember that x by 2 lies in the first quadrant. Since it lies in the first quadrant, negative value will not be accepted, but this positive value will be accepted. And we reach tan x by 2 is equal to 2. We reach, therefore, let me get rid of all of this. Let me get rid of all of this, except for the fact, do not remember anything except for the fact that x by 2 lies in the first quadrant. So therefore, tan x by 2 is equal to 2. That's the first thing. And after this, what you can do is simply draw a triangle, and you can find sine x by 2, cos x by 2 very easily. But when we want to solve analytically, what are we supposed to do? Drawing a triangle is pretty simple. This is something which you can do in the rough. Tan x by 2, if this angle is x by 2, 2 over 1 is this value 2. This will become root 5, and sine x by 2 will become 2 by root 5. Cos x by 2 will become 1 over root 5. That's pretty simple, right? That's pretty simple. The values will be positive since x by 2 lies in the first quadrant. But using analytical approach, what do I have over here is sec square x by 2. I will relate this with another trigonometric function. Sec square x by 2 is equal to 1 plus tan square x by 2. And with the help of this, I can find cos x by 2. Let's do that. 1 plus 2 square is 5. So you have sec square x by 2 is equal to 5, implies sec x by 2 will be equal to plus or minus root 5. Now which value will you consider over here? X by 2 lies in the first quadrant, therefore sec x by 2 is equal to root 5 only, the other value is rejected. Since x by 2 is less than pi by 2 greater than pi by 4, that is in the first quadrant, right? Using this idea. Once you're through with this, sec x by 2 is root 5 implies cos x by 2 is pretty simple. Cos x by 2 is 1 over root 5. Oh, but this is what we obtained over there. Yeah, that's what you obtained. You have already obtained this in the rough. Cos x by 2 is 1 by root 5. This is using analytical approach. What next? What about sin x by 2? Can I find sin x by 2 as well? Yes. Tan theta is sin theta upon cos theta. So sin theta will be tan theta times cos theta. Tan x by 2 is 2. So cos x by 2 is 1 by root 5. 2 over root 5. This is the value of sin x by 2. Is that okay? Yes, sin x by 2, tan x by 2 and cos x by 2. This is what I obtained, right? This is a complete solution that's done, but we could have started in another way. Maybe somebody would like to start in another way, and that is instead of beginning with tan x and finding tan x by 2 first, we may want to convert this tan x in terms of cos x first and then apply cos x by 2 formula and maybe get the same result using a different approach, right? We'll see in another question maybe the approach using cos 2 theta, but for now this is sufficient.